Okay. So welcome to csci 325 Object-Oriented Programming. Beforehand, this was called Java 1. The change is mainly because in this class, we're going to focus really on object-oriented programming, not so much on the Java programming language. You're still going to learn Java here, but in reality, we want to focus on object-oriented programming, which has become really the pervasive way that most programmers actually program out in the field. So I've started this class off different ways, and I think the way I did it last time actually worked out pretty well. So the thing about what we've done so far, and beforehand you've taken Intro to C Computer Science or Intro to C++, and you've learned a lot about the basics of programming. In OOP, we're really going to talk about how do you actually organize your programming so that you can work in large groups. So a good way to start off is actually just showing you how objects work. But before I begin even then, is there anything big or anything computer programs you actually enjoy so far or you want to see happen? For example, last time, two people right here were all about Pokemon, which was fine. So I wrote a quick little Pokemon problem just to show you what OOP kind of looks like.
I say it worked pretty good.
Yeah. It worked? You like the Pokemon one?
Yeah. Hey, you can keep using it.
You can keep using all. That's true, I could.
Add more stuff that you can use.
It's a terrible idea.
It was the running class project. Of course, some people weren't too big of a fan of that, but if you have any other ideas, I'm wide open to them. Some people want to see Tetris. Come on, guys, you got to give me feedback, otherwise it's going to get really long and boring.
Yes.
It will.
Yes.
It will. Thank you, Tyler. Any new games? I think the big thing then was Pokemon Go just came out. Are there any other big games that just came out recently? Nope. It's still the big one.
No, it's not big.
Not too many? Well, come on, guys. We got to come up with something.
They released a new generation.
A new generation? Are there different things about it that you like?
Oh, no, they just released the second gen Pokemon.
Second gen Pokemon for
the game. They just added them.
Oh, they just added them in?
Yeah, they just did the quick little...
Boop.
There you go. Have fun, everybody.
Any other suggestions? Because you can do this again if y'all want to. For those who've been here last time.
What? Nobody.
No one's been here before. Everyone passes this class perfectly, yes.
With an A.
With an A.
Quick question.
Yes.
Why's your screen tilted?
Because the projector is not right. If someone wants to try and jump up there and fix it, that'd be great. Yes.
Well, I am not at home, so.
What room number is this?
208.
Okay. I'm supposed to be over there.
Yes, if you mean to be taking Intro to C++ or Computer Science, it's next door.
I should have noticed when the textbook that I got didn't okay, yeah.
Did not match what was going on. Yeah, you know.
It
That's
was nice seeing you guys.
Well, good.
See you next.
Next semester. All right. Well, hopefully I'll see you next semester. Yeah.
Yeah, I don't want to see you.
You don't want to see me again. Thanks, Tyler. I appreciate it.
Do these outlets work back here? It doesn't seem like it's working.
Do they work sometimes?
Sometimes. Should I just try all of them, or should I just say they're not working? So not try?
I try a couple and then give up. Okay, guys, come on. What do you want me to do? I really can do Pokemon again if you really want me to, but we can do something else. You can't think of anything?
It's too early in the morning, man.
Too early in the morning. Oh, you didn't think I was going to ask you a question right off the bat? Oh, man.
Yes, I was.
You're going to have... You better get used to it.
Good introduction.
Good introduction, nice and small, simple, so you can just lean back. No. We got to jump right into it.
Then we can do chess.
Chess? Yeah, we can do chess. Yeah, we can start doing chess. And maybe someone can start setting up an AI. Anyone against chess? No? Awesome. All right. Let's see. How are we going to do chess? So we got chess. Okay. I'll call it the chess project. Okay. So I'm going to be doing a lot of things on the board, but in reality, we'll go more in depth about what's happening. I just want to show you overall how the whole process looks. That way when we start going into each bit of it, it'll make a lot more sense. So in chess, let's think about chess real quick. What is there in chess?
Pieces and a board.
You got pieces and you have a board. So those are two different, you could think of them as objects. that are in chess. Anything else can you think of?
People.
They're people, right? So you have
Oh.
players.
Most of the time.
Most of the that's true. So you could call them people, but better word would actually be player, because the player could be a person or it could be an AI of some sort. Okay, well that's great. Do you see how we've already divided 3 different things here? We've made one is the chessboard, one are the pieces, and another are the people themselves, or the players, I should say. So a nice thing about OOP is that now that you have 3 generic divisions, you can actually create 3 different objects for them. So, for example, we'll go ahead and I'm just going to make a package right here. I'm going to call it chess. We'll talk about that more later. But I'll go ahead and create a Java class, and we'll call it the chessboard. I'll make a new one. I'll also call it, what do we have, a piece, chess piece? And piece, I hope I spelled that correctly.
Which one?
Good.
You didn't spell it P-E-A-C-E, so.
Yeah.
Thanks. You have player. Okay. So what are these that I've created? They're in Java. They're called classes. A class is a blueprint for an object. So you create one class, and you can make any number of objects from them. Well, let's go ahead and jump up to the chessboard. So what does a chessboard have?
Spaces. Squares.
Squares. All right, so it has different squares inside of it. So we need to come up with a way we can think of different squares on a chessboard. And,
Array. 2D array.
yeah, a 2D array, right. So we can make it a 2D array. And if I recall correctly, it's 8 by 8.
Yes.
Yeah. All right, good. So then we,
Nerd.
what?
Nerd.
All right, so we need to create some sort of array, but we haven't decided exactly what is going to be in each of these spots. So in each of these 2D arrays, we need to of this 2D array, we need to think about what's going to be in each spot. What would be in it?
Either pieces or no pieces.
Right, either be a piece or no piece. Nice thing about OOP is that you can actually do that with objects. Either there is an object in that space or there isn't an object in that space. So I can actually create a 2D array of chess pieces. I'll just call it the board. And if I recall correctly, it's 8 by 8. It does not. Oh, this is Java, not C++. So let's start off the right way.
C, so much better. C++ is so much better.
It does allow you to do a couple things that are nice. That's true. All right, so we have actually our board. I called it mBoard. I use the M because it's a member of the object or class chessboard. Is it hard to see back there? No. Are you good? All right, good.
Line back there.
Wait for me. Okay, so if you're in a chessboard, or yeah, the chessboard, it has the board. What operations can you do to a chessboard?
Move it. That's not it.
You can move.
Fold it up sometimes.
Okay, you can fold it up. But if we're playing a game of chess digitally, does it really matter if we can fold the chessboard?
You can throw it.
You can throw the
It's gotta
chessboard.
be like you press E and it just like tosses the board.
Rage quit.
Yeah.
All right, we'll go ahead and we'll have that fun one. Public void flip board. We'll talk about that later.
Rage quit.
Huh?
Rage quit.
Bridge.
Yeah.
Actually, if we were inside Flipboard, maybe we'll do something system.out.println. I quit. I quit. And then system.exit, which would simply end the game by exiting the entire program. So, all right. So that's a little extreme. But what else can you do to a chessboard?
Another pieces.
You can what? Move a piece. Oh, all right.
Wouldn't that be something you do to the piece though?
Yeah.
You could do that to the piece. That's correct, but on the board. Yeah, you're on the board is what you use to move the chess piece, because the board is actually holding the pieces here. So we want public void move piece. If we're going to move a piece, what do we need?
A place to put it.
Not only a place to put it, but
A place to put it.
You gotta know
Place.
how it can move.
hmm?
You gotta know how that piece can move.
Right, we got to know how that piece can move. And who actually should be in charge of knowing how that piece moves? The chessboard or the piece? Piece. Ooh, okay, there we go. So that's great. Let me put that as a comment. Ask a chess piece if the move is valid. So we do need to do that. But what else? What if we want to move a piece? What information do we need?
You need a start point and an end point.
Right. We need to know where we want, which piece we're moving, the start point, and where we want to move that piece to. So I'm just going to, for simplicity, just go int start x, int start y, int destination x, and destination y. So we'll have s equals start, d equals destination. And by the way, if I don't comment my code much, please catch me. I've been doing this for so long, I go into autopilot sometimes. So let me go ahead and jump up here and go ahead and comment. Java, just like in C++, double / is a comment. So let's see here. Chess board will be represented by a 2D array of chess pieces. Okay. So move the piece. So first off, if we want to move a piece in the chessboard, what do we need to do?
Pick a piece to move. Pick a piece to move.
Pick the piece. Well, we have the start x and start y. So hopefully hopefully you can ask if that's actually a valid move. Well, before we can even ask if that's a valid move, we need to do what?
Find the pieces.
Find the piece. Right. So we need to actually see if there's a chess piece there.
That's why.
Thank you. So first get the piece, or we're actually going to try and get the chess piece at that position. Now, one interesting thing about Java here, since we're using objects, if there is no piece at that location, this is still valid. What's going to happen is chess piece or piece itself is going to be null. So the way we check if the piece is there, basically, if there is a piece at that location. So that's where we go if piece does not equal null. Null is actually a keyword inside of Java. If you're an object, if the object does not exist, it is null. So what's actually happening here is I'm getting a chess piece at that board location, and I'm checking to see if that piece actually exists there. Okay. So if it does exist, up here someone did mention that we need to find out if it's a valid move. So now what we want to do is ask the chess piece if the move is valid. So if piece dot, we'll just say is valid. Let's see. And we haven't written that function yet, but it can easily be a function of piece to ask if it is valid. What will we do once we check if it's valid, or if it is indeed valid? Move the piece. Now, when could we move the piece, or when could we not move the piece?
If it's not valid, you can't move it.
Right. If it's not a valid move, it can't be moved. Now, the piece is valid is asking the piece, can you actually move in this direction? The knight has the L shape, the bishop can go diagonal, so forth and so on. But what else might be a problem?
There's already a piece on the same side, or where?
Right. Right. So if the piece is on the same side, so if it is valid, and really we need to also ask, we also need to ask the piece if it's the same. What should we do? Same. We'll say same side, same color. Sure, same color, and we'll have to get the piece at dx, dy.
What could be like not same color?
Right. So we'll put the not in front of it, and there we go. And destination is not the same, or and the destination does not have a piece of the same color.
What about pawns?
Yes, what about pawns?
Because, I mean, moving forward is a valid move, but if there's a piece in front, it can't move there.
Right, so it can't have a piece in front of it. So right now, yeah, there is a, the piece right there is not the same color, and you also don't want, well, the piece is not there in the same color, that's true. And then, yeah, with pawns, it must go diagonal to capture. All right, yeah.
You can move the king to a place which the opposite side of the X.
Right. So, hold on, I want to try and make this simple for us, at least right now.
Leave that.
Maybe we should have done checkers.
Checkers? It's checkers would have been simpler. That's very true. It would have been. But we're going to make this simple chess, and we'll just say that that's our only requirement for now. Obviously, this is not correct at all. Not correct.
I've been playing like this.
Good, but and move the piece. All right. If that's the case, then in order to move the piece, we'd have inboard, so destination X, destination Y equals piece. Now what's interesting here is that if there was a piece there of the opposite color, it will have just have been overwritten by this move. All right, again, not completely valid in chess, but we're just going to do it this way.
We also need to remove the piece from the original position.
Correct. Because now we need to have inboard sub sy equal to null. So go ahead and move the piece. So you copy it to its destination, and then you null out the original location. When you put null, that aka it's empty now. Null, void, empty, nothing. It's all the same. 0 in C++ is actually null, but in Java, 0 is not null. That's separate. Okay, so we have move piece, and we've talked a little bit about chess piece, but because we're using two functions right here, I'm going to see, are we allowed to actually go to? Nope. So let's go ahead and jump over to chess piece. And we need public, what was it? Boolean is valid. Make sure I type that correctly. Yep. And start X, and start Y, and destination X, and then destination Y. And then the other one, we're going to go ahead and just return true by default. And then the other one was Boolean is same color. And this one, you actually pass it a chess piece. Okay, we'll just return false for now. All right, I just stubbed out the functions of a chess piece object. I haven't implemented them yet. Stubbing is really just writing the heading and giving some default response just to get the function out there so we can look at it. All right, we're thinking of a chess piece. What does a chess piece have?
A name.
A name, okay. Give it a name. But more specifically, its name actually describes its movement or its type, so to speak.
I see what you did there.
You see what I did there?
Putting in the type.
Gotta get that word type. So private, let's see. And we'll have the type just be an integer, just to make our lives a little easier right now. And what else does it have?
Color.
Color, right. So we'll have zeros, pawn. What else we have? One is rook, thank you. We'll have 2 equals the bishop, 3 equals the knight, 4 equals the queen, 5 equals the king. Did I miss anything? 5 is the king. I think that was everything. 0 is black, 1 equals white. All right. All right, so is valid. This function can actually start getting a little complicated, but how would we do is valid here?
We first need to check for what piece, what type it is.
Right, so we need to do a type. Anyone think of a good control statement from Intro C++ to use here?
Switch.
Switch. Why would we want to use a switch?
Because there are many types so we have to have many ifs and else's. If we
Right, so instead, nesting a bunch of if-else's, we can just use one switch to actually set everything up. So we can do switch, we'll do it on the type. You can have case 0, case 1, case 2, case 3, case 4, and then case 5, and then we'll have a default, which return false, because that doesn't make any sense. Naturally, we need to have our break statements in there, so let's go ahead and stub that out. Okay, so if it's a pawn, what would the valid move be?
Forward. One
Well,
space. Well,
now that's
default move.
Yeah.
It's 2. It can be 1 or 2 spaces.
Right, so this one's actually going to, again, checkers would have been easier.
Yeah.
But
just do one space.
it will just do one space.
I think every action does 1 space, no matter what. Because you sort of forget about the set space they can move.
I mean, you gotta move all the pieces.
So if we're moving one space in the y direction, basically x isn't going to change. So I'm going to go ahead and try and set up a return statement. So return sx must equal xy, and how do we check the other thing? Ooh.
dy equals like.
The destination has to be
different by 1, but in what direction?
What direction? Oh, there we go. Now we got a direction problem.
You can only go forward with pawns.
Right, you
Yeah.
can only move forward. Pawns only move forward. That's right.
We need to like visualize the board and the y's and the x's.
Right,
we
so
understand what is forward.
Right. So which one's going to be? Is white on the top or black on the top?
Actually, it depends on who's white, who's black.
Right.
Well, black is, I guess.
What is it traditional? I don't remember.
It
depends on how you're looking at the board.
Right. We just have to pick one.
Black is the top.
Black is the top. All right.
So that means.
So we're going to write here. We assume black is on top. Okay.
We also need to check color because that means if it's a white pawn, then it moves 1 up, and if it's a black pawn, then
One down.
Okay. So if, let's go M, color is black, then we'll go ahead and return, S equals SY, and now we have to have, if it's on top, and, ooh, yeah, what are we saying?
SX equals DX.
Oh, I'm sorry, thank you.
That's just the same.
DX, thank you. I said one thing and did another. It happens. All right. So make sure that the destination x values are still the same. And if it's black's on top, and we'll assume,
dy minus 1.
you may not be used to this too much. By the way, hello online people. We'll assume for the sake of argument, because this is how computer science does it, 0, 0 is up here. And then 7, 7 will be down here.
Means plus 1. dy equals SY
Yeah.
plus 1.
Yeah, so then let's see, dy must equal sy plus 1. Else, we'll do the same calculation, except for dy must equal sy minus 1. Is that correct? Yes. Good. And then Java does something here, unreachable statement, so I actually have to delete this. All right, we're going to stop right there. We'll just stick with the pawn for now. So we have a pawn. We can ask if it's valid. And then what was the last piece down here? We have, is the same color chess piece. Oh, well, how do we figure out that? Well, notice that this one's actually being passed the class, a chess piece itself, so we just really just do piece.m color equals my color, and then we're done. That was actually fairly simple. What's happening here is, since your class is representing is a blueprint for an object, when the object function is same color is called, it's being passed a second object. So you have me, the object, and a second object coming in. So in order to test the two, you just ask is the object that coming in, aka piece.mColor, the same as my color. And just return if those two are the same. Okay. So at least we have something started. Looks like we still have a little red over here. It looks like I called it same color when really it's by convention better to say is same color. All right. Now there's a lot of other little things that we can do to get this going, or we need to. First off, it's a chessboard. We haven't actually initialized its dimensions yet, so we need to go up here and do that. And we just had to choose a 2D array, didn't we? Public chessboard, and this is a constructor. A nice thing about a constructor, it's always called when the object is initialized. So mBoard equals, let's see, new chess piece, and if I recall correctly, this fails miserably. Oh, it liked it. Good. Phew. Chess piece. Sometimes Java doesn't like this, but it worked. So now we actually create a board of 8 by 8 possible chess pieces, but we haven't actually populated it yet. If we want to populate it, we need to actually, so we first create the board. Now populate with pieces. So if we want to go and populate the pieces, I'm just going to create the pawns for now, because it might take a little longer to get everything else up and running. So we have, what do we have? mBoard. So on the white side, or black's on top, you have all your standard ones there, and then starting on x1 and moving across, you would have your different pawns. So sub 1 sub I would equal new, what do we got? Chess piece.
White. Isn't it white?
White was 1, not X. You start at 0, 1. Not 1, 0.
Okay, hold on. One, 2, 3, 4, 5, 6, 7. There we go. So that would be 0, 0, and then this right here would be 1, 0, right? Or are we doing it differently?
Well,
Then it'd be 2, 0.
What would be 2, 0? Then over here would be 1, 1. There's different ways to look at it.
so we're having
I could-
x-axis going down instead of across.
We could do it that way too. Sure, we'll do it that way. That's fine. We can go 0, 1. It actually doesn't matter too much in this regard. Sure, we'll do it that way. So then that would be its y value, and then that would be 1. We'll have to keep that straight, but that's fine. Equals a new piece. Well, we need to come up with a way to tell what piece it is. So again, we have a constructor, and what's nice about a constructor is you can actually give it a default function to set the piece. So you go int mType, or type, and then you also want color. And then right in here we just have mType equals type, and then mColor equals color.
I have a question.
Yeah.
So in C++, we had to do it the way you first did it. In here, you can reverse your x and y axes.
It depends on how you want to look at it.
Because that's sort of what we did.
Okay, we'll stick with it this way. Yeah, it actually doesn't. For this program, it does not matter.
Okay.
It really depends. Different languages are taught to be either row major or column major, and that'll make more sense when you take architecture. But for this class, for what we're doing, it actually just doesn't matter which way to do it. But we can do it this way. That's perfectly fine. So yeah, then you're at 1, 0, 1, 2, 3. That's fine, and then you go. That's fine. We'll do it that way. And in C++, it technically didn't matter, but it was better to stick with just one way. Otherwise, you're going to get very confused.
Yeah.
But if everyone's taught to do it this way, I'm going to do it this way. All right, chess piece. We need to give it its type. Pawn is 0, and color 0 is black, and that's going to put black on top. So this puts a black piece on top. Put black, whoops, pawns on top. Now from this, can anyone guess about how put a white pawn on top? Just realized I made this plural when I didn't mean to. Inboard okay, I6, sorry, I couldn't hear you. Was new chess piece. Yeah, 0, 1, because we had 0 be the pawn type and then 1 be the color. All right, and this would actually, if it works properly, populate the board. So, before I go on, let's actually make a driver class for this. And there's different ways to go about making a driver. I'm going to just make another class called main, just for sake of division and clarity what's going on. And whenever you want to write a main function, it's public static void main string args. And let me put in my brackets. Okay, this is int main. Did y'all have to do int argc and argv as well, or y'all just did int main? Int main, yeah. So this is int main. What's cool about Java is you can have more than one int main, and you can select which main function you want to start at. So this main class can have a main function. Even the chessboard could have its own main function as well. But if we're trying to actually create a board here, we need to first create the chessboard. So chessboard, I'll just call it CB for lack of a better name. So here we create the board. Now this is what's very important to understand. Over here, all this coding does not actually create the chessboard object. Nothing was created in this code. Your object was not instantiated or created until you're over here in main and you actually did chessboard space CB. That's just calling, we're going to have CB be an identifier that points to a chessboard, and then over here is where we actually created the new chessboard object. Did y'all do anything similar to this in C++, maybe with structs?
I mean, we did do structs.
You did do structs towards the end? So class in Java is really a struct just with a ton more features added to it. Because in structs in C++ technically cannot have functions. They can only have member data, and there was other couple syntax things you had to do with them. But classes in Java are far more powerful. They have a lot more features with them. But you notice right here, instead of starting with integer, int, double, float, char, or string, we have defined essentially our own type called chessboard. And that's also what an object really does, or a class. It defines a type for you, aka chessboard. And by defining a type, you can have 0 or more of those types in your program. So right now, we're only going to have one board in this program. Yes?
Are we going to go back any? Because
Oh, yeah.
Okay, just making sure, because I don't know what program you're using or anything about what you're
Yeah, I'm just doing this to just run through the whole thing, give you a high-level view. Well,
Okay.
I kind of drill down sometimes, just high-level view of what's going on.
Okay.
I'm really harping on this because I've had so many students not understand that the difference between a class and an object. So I'm really trying to make sure it's clear. A class, there is only one. An object, you can create many objects from one class. I get that piece of confusion. If I can just get that drilled in today, I think everyone's going to be a lot better moving forward. I've just had so many issues with that because later on, if you don't get that, everything else is just going to be confusing. So the chessboard, that's actually a function which is calling this constructor, which is this function, creating the board and creating a bunch of chess pieces in there. Last thing, just so we can actually see that we're doing something, let's do public void print. All right, now I got to think of a good way to print this thing out. Let's see. What would be a good one? I just want to print the board real quick. So we'll go for int I equals 0, I is less than 8, I plus plus.
Then you could do the square brackets.
Yeah, maybe we can do square brackets. And then for int, j equals 0, j is less than 8, j plus plus. So we'll just do we'll get the chess piece, CP equals mboard sub Now, how do y'all want to do this? We have the first value is, right, you have the first value is I. Okay, that's fine. Just making sure it's clear, and then J. So I typed the heading correctly. So if CP equals null, or actually, yeah, we'll do it that way. We'll do system.out.println. Did y'all use cout? All right, so Java's going to do it a little differently. You don't use cout, it's system.out.print or print line. Print line will print everything and then a line at the end of it. So we don't want print line, we just want print. And if it's empty, we'll just do an E. Otherwise, well, right now, the only thing that's allowed is a pawn. So for the sake of, well, actually, let's go ahead and make this even easier. Let's go ahead and do system.out.println. We'll just print the chess piece right there, which is completely legal in Java.
But is it supposed to print? Like, we need to
Yeah, let's do print.
do new line after each.
Oh, yeah. Okay, we'll go ahead and do that right now. So after the whole line, we'll do system.println. Yeah, that's perfectly fine. But what I was pointing out here is since we're trying to print the piece, we have to tell Java what that is. And Java actually has a very special function, public string toString. And here is when Java will ask your object to convert itself to a string. So just for simplicity, I'm just going to always convert it to a pawn, because that's all we have right now. So we're back here on main, we create the chessboard, and then if we do cb.print, it should actually print this out for us. Now over here, I'm going to just go ahead and run it. Don't worry about what all that just was. It's going to take a while to compile. Java does take a lot longer to compile than other languages. Yeah, that's what I thought. It got printed backwards due to the row major order, but that's fine. We can fix that real quick by just chessboard. Where's print? There's print by just swapping the J and the I. There we go. So E is empty, and you have your pieces. All right. So that might seem a little. So actually, this is a great point to just stop and ask you a couple of questions. Is there an easier way to do this?
Probably.
Did I have to divide everything out in objects? No.
Does it help? Yeah.
It does help. Why would dividing everything out in objects help?
You don't. You got a whole bunch of jumbled mess.
You got a whole bunch of jumbled mess. What is the advantage of dividing it out like this so much? Can anyone think of?
Easier to solve the problem.
Easier to
find out where you have a problem.
Okay, easier to solve problem. Well, maybe. That I would say that depends. But if you're in a group of people, why would this be better?
Each work on the part.
Each person in one section.
One section. How has the sections been divided out?
By class.
By classes. So one reason why OOP is used so much is that by dividing each section out into class, you can then assign ownership to each object. One programmer is in charge of the chessboard, another programmer is in charge of the chess piece, and they are owners of those pieces or sections of code. So they need to make sure their code works properly. If there's a bug, you know who to talk to because there's ownership in the code. But why is this more complicated? It just is. The reason this is more complicated is now you have to agree on things. For example, right here we have the chessboard has to interact with the chess piece, and the two programmers that may be working on the chessboard versus the chess piece have to agree on certain functions. For example, they have to agree that there is an is-valid function that takes certain parameters and returns a correct result. Same thing was is same color. So before they can actually start working on their separate pieces, they have to agree on how their objects are going to interact. Now, luckily, they can just stub out what the functions are, just the heading, and then later on the programmers can jump in and actually code it. But realize that here, that when you're moving forward, that there is documentation or communication issues at that point, because you have to actually agree in the beginning. And I don't know if you worked with too many programmers. It can sometimes be a little difficult to agree. And also, if it changes later, hopefully you can see that that would actually be can be pretty drastic, especially if you have tons of programmers working under the same function. But any questions about what I just stated? Let's go ahead, since we got this far, at least get something going. So we'll do cb dot. Let's see. We have move piece. We have 0, 1. We'll try and move it to 0, 2. And then we'll do cb.print. Let's see if that actually, what happened here? Cannot resolve move, what do I call it? Move piece. Let's go ahead and run that real quick. Let's see what it looks like. Ooh, exception is same color. No pointer exception. Ah. All right, I'm just going to fix this for now. Does not equal null. There we go. We'll talk about that later. And before I go in, let me put some type of dividing line so you can actually see the differences. Okay. So you can actually tell up here, empty and pawn. And then down here you can actually tell that the pawn moved 1 down. If I try and make an illegal move, 0, 2 to 0, 1, we'll go ahead and copy this real quick just to show you that it did actually, or at least hopefully it stopped it. Yep. Right here we have the pawn moved down by 1, but when we asked it to basically move backwards, it did not accept it. And so you can actually start setting up different moves and then maybe later go into adding different pieces as well. All right. Any questions? Anything else you want to see before I move on? I think this is a good place to stop and actually start going more into the class itself. No? Okay. Great. Thank you. All right, OOP. I'm Dr. Paul West. Let me go ahead and jump in. So a computer is made of hardware and software. The hardware is actually the physical components. Your program is the software that runs on it. As computer scientists or programmers, you're mainly concerned about writing programs or your series of instructions. No one here is an EE major, so you're not really concerned right now about hardware. Although, if you are interested in hardware, when you take computer architecture, that's where we start delving into how you actually develop or create processors. But we're going to be concerned about the software here, which is programs and the data the programs use. The programming language is basically the words and symbols we use to write the program. Bless you. Java. Bless you. So that's it. You don't get any more. Java language was created by Sun Microsystems, which is now owned by Oracle. It was introduced in '95, which was actually a while ago. But its popularity has grown substantially. And let me see if I can find its current indicator here. We'll go and... Oh, they changed their website. All right, Google. Index for January 2017. Let's see. Oh, wow, look at that. Java is up by 17%. What this is TIOBE does basically an indexing of figuring out which languages have been used the most. Obviously, any type of indexing is not going to be perfect, but it gives you a good general view of what's going on. And this is done by basically how much traffic, people talking about languages, people actually submitting code in that languages, et cetera, et cetera. And as you can see right now, wow, Java has a commanding lead over all the other languages. Java's #1, is used a lot. C used to be #1, and we'll probably still hold up there for the time coming. Then you got C++, C#, Python, et cetera, et cetera. So the reason why we chose Java, or Java is used, is mainly because of its popularity. And when you go out and work, chances are one of your first languages you will use will actually be Java. So this course will actually propel you there for that. Are any of these other languages familiar to y'all?
Yeah, Python, for example.
Python? Yeah, Python's been growing steadily. That one's just been going up steadily, which is nice. I do prefer Python over a couple of the other choices.
It's very simple to just get in.
Yeah, it's very simple to get up and running. Any of y'all use C#? So C# is essentially Microsoft's version of Java. Java came out a little later. Microsoft came out with their version of what Java essentially is and called it C#. In my opinion, I actually prefer C# as a language. The issue is that for the longest time, they would not open source their implementation. So what happened was all the documentation and trying to develop it for other operating system was closed by Microsoft. But now they've opened it, so maybe it'll take over at some point in time. But C# and Java are a ton of similarities to the point where if you ever have to convert between Java and C#, really you're just converting between a couple of syntax changes and a couple of library changes, and then some really, really advanced nitty-gritty corner cases that you have to be aware of. But besides that, the languages they behave essentially the same.
What are the biggest differences between them? Like that would what do people go on when they choose?
When they choose, what they have to use. So Java historically they've always supported Sun from the beginning, open source community. From the very beginning, they had an open source, basically called a group that managed Java, made the design choices about Java, what was going to happen next. The implementation was open source. You could take it, come up with another implementation for different architecture. C#, owned by Microsoft, run by Microsoft, everything is Microsoft. You drink the Microsoft Kool-Aid. That's what it is. So if you are a Microsoft shop, you chose C#. If you're not, you went with Java, is essentially what it came down to. There's plenty, hopefully you can tell I'm not a Windows person. I'm definitely a Linux guy. So you know where my loyalties lie. But see, Microsoft is not that bad. They actually do a very good job of supporting their users. But at the end of the day, you'll see me using Java, not C#, even though I actually prefer C# as a language. But yeah, it's really just historical reasons what you started with. And C is really good for kernel development. C++ actually use a lot for game development. That's what it comes down to. Well, you use Python. JavaScript is used all over the place for web development.
What about the change? Because it looks like
the changes,
one of the highest.
I'd have to look into it, but usually when the change is this big, it's because they changed their the way they did their indexing. So they might have done some index changes. But this is normal. You'll see Java and all these languages go up and down a lot. Let me see if I can click on one, and if it'll. So you can see Java. Well, it's actually been slowly going down in a way, but it goes up and down quite a bit. I think what was the other one? C. And they might actually have a graph down here. Oh, beautiful. Here, perfect. So C plummeted all of a sudden. I'm interested. I'll have to look up why that just happened. Because tons of projects are in C. The Linux kernel is C. Uses C. But yeah, usually Java and C just compete between who's number one, and then you have everyone else. C++ is usually leading the pack down there.
So some of those languages are really, really new. It looks like 2010.
Yeah, some of them. Yeah, what was our?
Like anything is trending up.
Yeah.
Everything's trending down.
Everything trends up. Yeah. Right. Well, I would say. Well, C# has gone up and down a bit. Yeah. These.
Assembly languages.
So assembly language, I think that's okay. Ignore that one. It doesn't make any sense.
Well, it's moving up.
Because which assembly language are you talking about? There's tons of them. So that I would ignore that one. Yeah, the big one I think is Swift. Is that one on this list any? Maybe not.
Alice was on there.
Get on there.
There we go. Swift is at 14. Swift has been slowly improving. It's what you use to develop apps on basically your iPhone or iOS.
Is there a lot of kids take Swift classes on iPads?
Yeah.
My younger sister, they're having them do that for beginner programming class.
Mhm.
It's easy.
Yeah, Swift really cleaned up a lot. Objective-C, I'm not going to, it's a very old language, so you can only knock it so much, but it was good at the time. But if you ever use it, there's a lot of antiquated syntax, and Swift really just cleaned it all up and made it easy.
PHP's going down.
Yeah, I'm a little sad about that, but oh well. PHP's going down. This one I thought was dead, Pascal. Like Go has been climbing substantially. Look at that. 54 about a month ago to 13 now. But yeah, different languages shooting up. Just to show you, Java has been holding number one for over a year now, for a long time. That's one of the main reasons why we chose it. That, and I know Java pretty well. Oh yeah. Any other questions? All right. So Java is made up for one or more classes. Java is an object-oriented programming language. That means that your code must be in a class. C++ allows you to do object-oriented programming, but it's not required because you don't have to use classes in C++ in order to write a program. In Java, you have to have a class. All right. Talked about main. Just a quick example. I typed some code, but in case I was missing a couple points, here's an example. Public class Lincoln. Public means anyone can look at it. We'll talk about visibility in a while. But right now, just put public in front. You have to, otherwise Java will, well, it may default to private, and then it won't work out too well. So make sure you start with public. Class, we're defining a class, not a function, or a data type, or using or creating an identifier, I should say. And then, of course, its name, the curly brackets, and then inside of a class, you're allowed to define functions. So that's what public static void main. Did y'all do static in C++? What did static do there?
I think it's saved when if a variable declared in a function was static, then when the function was exited, when the program exited the function, the variable stayed the same.
The it retained its value. Yeah, between function calls. Right. So the way I remember static is there can be only one, and there is only one. So there's just one. So on a function, that means there is only one main function. No matter how many times you create a Lincoln class, it will only use this one function, no matter what. So there is only one. Right, so you might have public class heading, and class body. Your comments are just like in C++, double slash for a single line, slash star to start a multi-line comment, and you end it with a star slash when you want to finish your multi-line comment. And you can do method headings are going to behave this very similarly, but you're going to have extra identifiers in the front, or modifiers, modifiers, public static, for example. Well, you could do static functions in C, but you probably did not use the word public very often, if at all. But again, function identifier, and then open in parentheses you have its arguments, and then you start with the curly bracket, end with the curly bracket. And the method body is in between. Comments are just like what we talked about earlier. We'll talk about JavaDoc hopefully later. Just a quick review in case it's been a while. Identifiers are the words a programmer uses in a programmer. They can be made of letters, digits, underscores, characters. They cannot begin with a digit. That's just like in C. If you're creating a variable, you're giving your variable a name, aka an identifier. It has to start with a letter or an underscore. It can't start with a number. But then afterwards, you can use a letter, underscore, or a digit.
Or dollar sign.
Or a dollar sign? Well, I haven't seen a dollar sign yet. I don't think you get a job. It doesn't say that? underscore and dollar sign? I've never done that. Is that really correct? That would be awesome. Private int money. Wow. Awesome. All right, you can use dollar sign. That's great. So was C case sensitive? Yeah. Same thing with Java. Still case sensitive. All real languages are case sensitive. So just assume that. Now, Java has actually a bunch of conventions, which means that there are standard practices people ask that you use throughout your program, although they are never enforced. For example, when you're defining a class, all of our classes, the first letter has always been capitalized. That is a convention. You don't have to do that, but please do that because basically everyone does that in Java. Don't be that guy. Sometimes we're using another program's code, so we have identifiers that he uses. Right, so print ln. Often we have special identifiers, reserved words. So if you recall what a reserved word was in C++, you've used them all the time.
You can't name your
variable.
Use them.
You can't redefine it.
Yeah, you can't redefine it. So examples, if, when, void, those are all things that switch as well, break. Those are all defined by the language. You can't create a variable called switch. That's not valid. Same thing in Java. You can always look online for the full listing. Here's the full list here, or at least I should say the start of the list. There are new ones that haven't made this list that I haven't gone up there. But a lot of these should look very familiar to you. Int, float, double, short. But there's some new ones that you should be aware of. Super, class. One thing to keep in mind is in Java it is Boolean, not bool. And there's a difference between byte and char, but we'll get to that later. And there is const, but there's also final.
Strict FP.
Strict FP, strict floating point? That'd be a good question. I haven't looked into that one. You're all used to white space. You can space things out with blank lines. The compiler will completely ignore them because when it tokenizes your program, it basically strips all your white space out and only looks at the actual keys. But of course, your white space is used to separate your different words. And what I mean by that is over here. Private and int is separated by a space. If you did that, they wouldn't be separate anymore. So there's some white space. You could use one space. You could use a lot of spaces or multiple lines, and that's just fine. Although please don't do that because that makes it hard to read, and no one likes that. Make sure you get them formatted correctly. If I recall correctly, Dr. Hayes has been pretty good about making sure you format in your class. All right. I'm going to be a little more lenient, but please, I'm going to have at least some standards. I mean, this, I might take a point or two off. Hopefully you can tell that you really need to indent that out. But if I see this, I'm just going to throw it back, okay? Don't write your code like that. That and the previous one, they compile and run the exact same way, but that's just mean. Don't do that to me. All right, real quickly about me. I got my PhD from Florida State in computer science, namely computer architecture. What that means as a computer architect is that I'm more of a systems programmer. I delve more into the kernel, the device drivers, actually building the system and actually having it work properly. My focus is not so much on web development because I am a systems programmer, although I do have experience there. Teaching-wise, I've taught here since the beginning of 2015, January 2015. I have 3 semesters at CFC. Work experience, I've done a good amount of work at SPAWAR here in Charleston. I worked a lot on their different communication systems. There I did do, actually one of my projects was in Java, but it was actually more of a desktop application, not a web application, which is very rare. So I have job experience there, and I also did a bit of architecture stuff, designing circuit boards, programming microcontrollers, writing device drivers, et cetera, et cetera. I did work at Google for about a year, basically as long as I could take it. And I worked on Android with their Bluetooth, Wi-Fi, and telephony, namely Bluetooth. So again, device drivers, making sure the system works. So if your Android phone Bluetooth starts to fail, it might actually be my fault. Sorry about that. But we tried to fix all the bugs. There were a lot. I didn't get to all of them.
You didn't like
So
Google?
who to blame then?
I did not like living in the Mountain View area, is what it had. Google's actually a great place to work because they really take care of you. You can choose your hours. You don't punch in a time clock. You just show up. They feed you. There's gym there. Everything's there except a place to sleep. They literally had a doctor on campus that if you needed to go see, you could just go straight to the doctor as well. And it was all part of your compensation package of working there. So it was a great place to work, but living in the Bay Area is a nightmare.
What does this Google do on 52?
On 52, that is a data center. So they are just maintaining a warehouse of computers to service basically act as Google in this area. Because Google's so concerned about latency that it's actually important that they have a station here in Charleston as opposed to having it in California just because of how long it takes data to cross the U.S.
So nothing actually happens there. It's just like storage.
It's servers. It's the warehouse. It's the backbone. But they're not developing anything. They're maintaining a server farm, essentially. Yeah, otherwise I'd be working there here. That'd be great.
Yeah.
That'd be awesome.
Are you allowed to tell us about the various government contracts?
Sure. Various government contracts. Yeah, there have been some decent ones. The big one I can talk about is I worked on VBMS last summer, and that was just another Java program, which is basically the management system for all your VA benefits. They submit all their paperwork, and just a system to handle all the paperwork, make sure they got all the check boxes checked off. They can actually get their benefits, so forth and so on. Because when I started that project and last summer, and I was amazed. I forget when it started. I think it was 2010 or 2011. And I asked, well, what did you do beforehand? And they said, oh, we just wrote paper down and mailed it to the office across the world, across the U.S. They would go into their paper files, find it, and then photocopy it, staple it to ours, and then mail it back to another place. So you literally had physical copies going around the U.S. in 2010. Well, in this millennium, we have a thing called a computer. You put electronics into it. It moves around. But anyway, yeah, I worked on that, and I worked on communication systems for the Marine Corps. Radios, a lot of it's security, so I can't go too much into it. But Marine Corps communication systems. And then Denim Group was probably the most interesting one. It's my first programming job. Did it for a year and a half, almost 2. It was a startup. I was employee number 7. And we did a lot of web design, building web pages, going in, securing web pages. That's when we had interesting dealings with government agencies as they came in to talk about security. But yeah, I did a lot of network security at that point, and that was a lot of fun, although can be hectic because startups don't always know when their next money in stream will come from, so you got to be aware of that. But yeah, if you have any questions about my work experience or faculty, please go ahead and ask. You can even ask me now if you want to, or after class. Okay, syllabus. All right, let's go over the syllabus. Oh yeah, I'm a Linux user, so I type everything in. It's okay. I don't expect you to use Linux in this class, just in case any of y'all are getting antsy about that. All right. Dr. Paul West, here's my phone number, my email address. Tuesday, Thursday, 9:30 to about 10:50. And the lab is for an hour afterwards. Okay, so we need to finish up soon. 208, that's this class. There are my office hours. I am a morning person. I usually get here between 6 and 6:30. I will probably not see me after 3 o'clock because I have to pick up my kid from school. But otherwise, you'll probably see me. I technically don't have any classes on Friday, so I don't have to come in, but I usually come in on Friday to get some work done. And you can probably catch me between 8 and 2, or 8 and 1:30, I should say, if you need to. But if you can't come by office hours, please make an appointment. If you have a question, just email me or talk to me right after class. We have an hour of lab. Please stay here for the hour lab and get your lab assignment done. I might get to assigning one today, but it's not too important right now. Oh yes, GitHub. Any of y'all used Git that were not in my previous class? No. All right. I drive all my classes through GitHub. I'm trying to make this easier and easier for students because almost everyone uses a repository system, and almost everyone uses Git as their repository system. Google used Git. My various contracts, they use Git. Tons of companies use Git. It's used everywhere. I'm trying to make this easy, so this time I'm going to ask you all to use something called Git extensions, which will hopefully make life a little bit better because it's more of a GUI-based app to do everything through Git. But most importantly, you need to give me your GitHub username. So after class, either come to me and tell me your GitHub username or email it to me and I'll give you the invite to our class because the class has to be private, so I need to do this whole username thing. But all your code will be submitted through GitHub, so there's going to be a good section about how you actually use GitHub and Git coming up actually next lecture should start the GitHub section. So make sure you know Git, or we're going to learn Git. Let's see, what are we doing? This course, exploration of OOP and Java. We will learn, okay, blah, 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 blah. All right. We're going to learn object-oriented programming. Beforehand, we had to learn a little bit about data structures. I think in this class, sticking with OOP is going to make more sense because you're going to learn about how you use those data structures in order to accomplish a task. And then in data structures, you'll learn about how they actually work behind the scenes. So that's basically the transition that has occurred. We're also going to have a little more time to talk about design patterns and how you can set up your code to work better with other people. All right, justify. Right, so in class, you're expected to justify your design, implement, test, describe your mechanisms, implement, compare and contrast. All right, different parts of OOP. Basically, we're going to really delve into OOP. All right, ABET. All right, you can read the ABET if you want to. This is required for me to put up, and we will, doing this, like, some of this is pretty generic. An ability to apply knowledge of computing and mathematics appropriate to the discipline. Well, that was nice and vague, but you can read through a couple of these. Teamwork. This course has a team project or a class project. You will be asked to work in groups probably between 5 and 7 people, and you'll all be working on a project throughout the semester. Start thinking of what you want that project to be now, because we have to actually get this started soon to make sure you have plenty of time to complete it by the end of the semester. I'll get more into that in a little bit, but for teamwork, the teamwork's only for the class or the team project. Afterwards, all your labs and whatnot are all about you, so make sure you work on those and not your teammates. Attendance and late. I do not enforce attendance policy. If you don't show up, that's your own fault, because most people who don't show up to class don't do very well. So I'm not going to take attendance. I have a fairly generous late policy. If you turn in your work late, it is minus 20%. If it is 1 minute late, it's minus 20%. If you turn in lab 1 on April 27th, 2017 at 11 p.m., it is minus 20%. Whatever. Once it's late, it's minus 20%, no matter how late it is. But there's a cutoff to how long I will wait to grade your assignment, and that is April 27th. If you turn it in after that date, I will not grade it. As long as you turn it in beforehand, I will at least grade it, and there might be a minus 20. Is there any questions about that? Okay, good. That's because I understand life happens, but we have to have deadlines. Yes?
Do you put grades on Blackboard?
Yeah, the grades will be on Blackboard. I haven't figured out how to do that correctly in GitHub. I don't think it makes much sense.
Yeah, because didn't we work out last semester?
With GitHub or?
GitHub.
I just.
Yeah, Well, depends on. Some people did just fine, others did not. So I'm going to switch to Git extensions. I think people were just confused about how to use it properly. All right, tentative schedule. This could easily change and probably will. But we're going to talk about, introduction, how to use classes, how to write them. Talk about inheritance polymorphism, which is really the huge point of using OOP. Then we'll talk about GUIs, because GUIs are actually a lot nicer to write in object-oriented programming than procedurally. We'll talk about SOLID, which are basically the 5 rule points of object-oriented programming, have a midterm. And then we're going to go into a couple of other OOP important, things to talk about. Exception handling, recursion, lambdas, which is becoming really, really popular in Java and most other object-oriented programming languages. And then hopefully we'll have time to get through a good number of design patterns, because these patterns are what you'll be using when you go in the workforce to make everything easier to work with. And then marshalling, which is a very important aspect in Java and a lot of web development. All right, ethics paper. We have to have an ethics paper. That's 5% of your grade. Midterm and final are 15. Your project is 15. Your labs and assignments are 50. Keep that in mind. Do not go late on your labs or assignments. If you do not turn in your labs or assignments, you're not going to pass this course. Please if you ace your labs and assignments, turn in your ethics paper. That's a 55. All right. There's not much more you're going to need to do to pass the class. Make sure you get your labs and assignments in. All right. Standard grading scale. If you're a student representative, please tell me so I can make sure you have the proper days off or whatever we need to do. Honesty. All right. Don't cheat. I get really tired of dealing with it, so please don't do it. You can read all this. Basically, don't use Google to find an answer and copy and paste it in. If you need help and you can't get it from the book, or I'm not available or something, yes, you can look online. Please, if you do that, just cite what you used. If you always cite what it is you're using, I cannot get you for academic dishonesty. Even if you copied the code in, I won't get you for academic dishonesty because you're at least telling me that you copied it from this website. You may still get a 0, but at least I won't get you for academic dishonesty, because the dishonesty, there is actually a process and it can have dire consequences. So if in doubt, just cite. In general, I'm pretty lenient about it. I understand you needed help. Is that clear? And you can just put the citation as a comment in your code. It's not too big of a deal.
Are you pretty available by email though?
Yeah, please, just email me. Up here with email, well, actually I was going to go over that down here, I think. Extra help, don't hesitate to come talk to me. One thing about email is my Sabbath is Sunday, so I won't be answering emails on Sunday, obviously. Saturday's usually family time. Probably won't get me on Saturday either. But the rest of the week I should be able to answer it. Keep in mind, especially the online students, that I can only guarantee I will answer questions during my office hours. I will try and answer them other times. Usually I get to all my emails on Friday, but when office hours hit, I make sure that I answer every single email I have in my inbox. So keep that in mind with assignments as well. But I'm usually pretty good about email. Course evaluations come in towards the end. Oh yeah, disability services. If you have a disability, come talk to me, give me the paperwork, we'll take it from there. Online students, all right, I understand some students must take this class online for various reasons. Be aware that I've learned from experience that lack of face-to-face communication is a disadvantage. It's just a flat-out disadvantage. Therefore, you need to communicate, online students, to me as much as possible. And if you have any problems, make sure you email me as soon as possible, because there's already a delay from when you get the video, because it's going to take me a while to upload it. So it's really all about communication. Class recording, I told you before, I record my classes and put them up on YouTube. And I post the link under Blackboard. These videos are unlisted, meaning that you cannot search for them. And that's just more of a protection, privacy for everyone. But you will have a link that you can view them from anywhere you want to. You don't have to log into YouTube to get it. All right, add drops on the 13th, midterms the 28th, withdrawals March 17th, and then withdrawal passing or failing, I looked up, was April 19th. Course final, the times were released, I just haven't gotten it up there yet. One last thing, does anyone have the book, or the 2 books right now? Yeah, I got the 2 books? Okay. Wish I had them in front of me.
I didn't bring them.
Didn't bring them. When it comes to Java and teaching OOP, I have yet to find a good book, period. I have never found a good book teaching Java and or OOP. It's like a curse of
It's
the
not the
field.
same one as it was last. Was it the same one as it
No,
was?
I've changed the books. Hopefully this will do better. I'm trying to make this simple. The object-oriented thought process is going to be all about the theory. It's telling you why we use objects, how to think about objects, how to use them when you're designing them. Okay, so that one's theory. Core Java for the impatient is all about practice. aka how do you actually implement an object? How do you make an object do inheritance? How do you set up recursion, et cetera, et cetera. So you have your theory book and you have your practice book. I did this because I've had a lot of students have difficulty understanding why we do things certain ways. So we're going to pretty much read all the way through the theory book. It's not that hard. It's pretty light from what I've read so far. Core Java, we're not going to go through all of it. There's too many features in Java, but you will be using at least some assignments from that one. All right. Any questions? All right. So we are good. We're running on time. GitHub. Create an account on GitHub. Email me. Your username. More instructions will follow. Group projects. All right. Start thinking of a group project. I've seen all sorts of group projects. I've seen people. First popular one's always a game. Someone may write Tetris or a text adventure. I've seen people write phone apps as well, keeping track of groceries or bank account or budgeting information. Someone's tried to work up on bringing up a web page as well. Just come up with any type of a project you'd like to see: apps, games, web client, etc. I had one person write a port scanner in Java as well, and that worked out well. I think I had another one who did an FTP client, and that was a good one to start off as well. The point here is, after your last class, you've really come to the point where you can start creating programs that actually accomplish something. So we need to start practicing or making sure you have that experience of actually creating an application. But additionally, we need to start getting experience working in a group, because you'll hopefully find out very quickly that working in a group is very different than by yourself. Right, Tyler? And the way this is going to work is you'll give me your ideas. I'm going to post the ideas, and then I'll ask you to email me what your top 3 are, and then I will essentially assign the groups based on that. In general, almost everyone gets their number 1 spot. I think last semester everyone got their first spot, but every once in a while I have to go to number 2. So that's the way it's going to work. Please give me ideas starting now, and then maybe in a week and a half we'll actually start assigning groups. Okay, any questions so far? All right, so we haven't gone into program development or the rest of this, because it's about as far as we've got. It's currently 10:50. Usually the last hour is for lab. So I'm going to go ahead and just I'm going to pause here for now. We'll go over these slides again next class. But one thing I want to make sure you all are aware of: read Chapter 1 of the object-oriented thought process by next class, and then come in and we'll go ahead and start discussing actually object-oriented programming then. Also start coming up with your project ideas. Please go ahead and email them to me. You can give me more than one. That's perfectly fine. But just tell me what your idea is and a little bit more about what it would do. Just, don't say, I like to make a game. Tell me what the game is. If you know it's Tetris, say Tetris. But you have a couple more descriptions, go ahead and do it. All right, any questions?
The theory one you said?
Yeah, the theory, object-oriented thought process. Oh, thought process? Whew, that's bad. Thought process. Through process, it's the through process. No questions? All right, well, that's all for today. If you wish to help you out and help me out, go ahead and log in, create a GitHub username, and come talk to me, and I'll just get you signed up right now, and that way you'll be ready next class to start GitHub.